Hello, welcome back. This is topic 2, matter, and today we're going to talk about separation of mixtures. So our aim for today is to describe the different methods for separating mixtures. So what do we know about mixtures? They're combinations of two or more pure substances that can be separated by physical means. Their composition is not definite or fixed, so they can be in varying amounts. The elements can be in different ratios. And each element keeps its own properties. So iron will stay magnetic and sulfur will keep its yellow color. This is one of our examples. And you can find that they keep their own properties. So the properties of mixtures, they allows the parts to be separated. And some of the ways that they can be separated are by filtration, distillation, and chromatography. So we're going to talk about those methods. Your mixtures can be made up of different amounts of two or more atoms of elements. You can have, some that are diatomic, some that are single atoms. You can have varying amounts. This is a mixture of two types of molecules, two types of molecules that are elements and compounds. So filtration. What mixtures can be filtered? So imagine you want to use a filter. So imagine filter paper. If you were going to pour a mixture through the filter paper, what type of mixture could you filter? And this would be useful if you have solids that are suspended in liquid, where the solid is not dissolved, like sand and water. That would be one example. So what do we know about filtration? The solid will settle to the bottom of the liquid if it's not disturbed. Okay, so you can pour the liquid off carefully from the solid, and anything remaining, you can then use a filter to separate the liquid from the solid. So how does a filter work? A filter allows small particles to pass through and traps larger particles in. So there's holes in the filter. So anything smaller than the filter, the holes in that filter will pass through and larger particles will be trapped. So the substance that passes through the filter is called the filtrate. Whatever remains on the filter is called the residue. So the residue is the solid particles that are left in the filter. The filtrate passes through. Okay, so you can see in this air filter there, that air conditioner filter, the air passes through and it traps solids like lint and dust. So the air passing through would be the filtrate, and the residue is what's left behind. So all that lint and dust that should be cleared off every so often is the residue. Cars and trucks also have filters. So the air filter should be changed on that as well. A separatory funnel is another type of filtration. And this is useful when you're separating two liquids. The two liquids that are not soluble in each other means they're immiscible, like oil and water. Immiscible means that they do not mix with each other. So oil and water separate, even though they're both liquids. So they are immiscible. And you can pour off the top layer, and then you'll be left with the bottom layer. The funnel will remove the more dense liquid. Distillation. Distillation is when solids are dissolved in liquids, like a homogeneous solution. Distillation can be used to boil off one part of this mixture and leaves the other behind. So you could use this for salt water. If you boil off, even though it's dissolved in the salt, you can't see it, it's completely homogeneously mixed. When you boil off the water, the salt is left behind. So liquids that mix with each other are called miscible. They have different boiling points, and they can also be distilled. So you boil one liquid off first, and it leaves the second liquid behind if they have different boiling points. So it takes a different temperature to boil off each liquid. Okay, here's a little fractional distillation setup in a lab. Chromatography is another method that's used to separate mixtures. So chromatography is used to separate different parts of a mixture when they have different attractions for substances not in the mixture. So it says in the picture over here, if you're looking at this picture, that it allows things to flow through and it separates them by their components. So different components flow through the material at different is when gases pass through a medium that separates the parts of the gas mixture. Some examples of Regents questions. By using a paper filter, which of the following can be separated? So let's think about where a filter would be useful, for what type of mixture. So two immiscible liquids. Remember, immiscible means that they do not mix together like oil and water. Two heterogeneous solids. So two solids, a solid and a liquid, or two miscible, which means liquids that do blend together. So which one would the filter be used for? This would be used for the solid and a liquid, like sand and water would be useful to use a filter. Another Regents Question example. Distillation can be used to separate. So distillation, remember, is for separating two liquids. Okay, so solids it wouldn't be useful for. It wouldn't be useful for solids, and it wouldn't be useful for gases. So distillation is used to separate two miscible or liquids that blend together with different boiling points. So choice 2. And finally, the principle that allows paper chromatography to separate mixtures depends on the different components having. So the chromatography is when you have the two components with different attractions to the paper. So it separates by the speed it moves through the paper. So that would be choice 2. And that's the conclusion of 2.2, separation of mixtures. See you next time.